Good morning, everyone. Hope that you had an awesome weekend. Um, so this week is going to start a little weird. Today, of course, we have a regular day, but tomorrow is not. In fact, juniors probably may not be here at school. Seniors, of course, will be taking the ACT. Sophomores will be taking the ASVAB, so we will not meet tomorrow. And then we'll be back on it on Wednesday. So, anyways, what I'm going to teach today is actually going to be pretty simple for you. So it'll be a good lesson to have on a Monday after a weekend, but also on a Monday where we're not going to be in class together again until Wednesday. So obviously we've switched over and now we're dealing with polynomials. So what I mean by that, or what that means is we're not dealing with just quadratics, okay? We're dealing with different types of polynomials. If you guys remember last week, we actually labeled them, classified them. Like, for example, right here, number 1, if we classified that, there were two different ways, right? One was by the biggest exponent, so 3, that would be cubic. But then also by the fact that there is two terms would be a binomial. That's a cubic binomial. But you can tell it's not quadratic, right? And when we factored last 9 weeks, we were always factoring quadratics. So this is going to kind of change the gear a little bit. But as far as the two types of factoring that we're going to talk about today, we're still going to talk about the very first one, the one that you've got to do every time you're asked to factor or to break down a problem, and that is greatest common factor, right? You got to look at it and think, okay, can every term, not just one term, can every term, can we find some value that will come out of both of those terms or all of those terms? So greatest common factor is first. Now, today we're going to really just deal with when we have binomials, okay? Then Wednesday we'll deal with trinomials. Actually, we're going to deal with special cases of binomials as well that day on Wednesday. And then on, I guess it'll be Thursday by that point, we're going to actually talk about how to factor a 4-termed polynomial using this method called grouping. Anyways, let's go to what is our first method always that we check, and that is greatest common factor. So you look at number 9, or 1, no, not number 9. You look at number 1 here, and you look at those two terms, and you think, okay, what comes out of 6 and 3? Well, definitely 3. And of course, the first term has x cubed. Second term has x squared. So the most we can pull out of both is x squared. So my greatest common factor, what I'm pulling out of both terms, and when I say pulling out, I mean dividing it out of both terms, is 3x squared. So that's what we're going to do. So look at this, guys, just to make sure you know what we're doing. We're taking 6x cubed, and we're dividing it by 3x squared, okay? We're pulling it out of there. Well, what is 6 divided by 3? Well, 6 divided by 3 is 2. And then if I had x to the third and I divided out x squared, okay, we talked about dividing with variables. You subtract those exponents. There was 3, we took away 2, there's 1 left. So we're left with that first term with 2x. Then we move on to the next term. The next term, of course, being minus 3x squared. Of course, what is negative 3 divided by a positive 3? Negative 3 divided by positive 3 is negative 1. And then x squared divided by x squared will cancel each other out, right? They're the same, so they're just going to basically erase each other. So we pulled out 3x squared, and it left me with 2x minus 1. That is the same process that we've already used back when we were talking about quadratics that were where we had a greatest common factor. So this is all stuff that's pretty familiar to you, at least it should be. Look at number 2. What will come out of negative 2 and negative 10? Well, 2, definitely, right? Well, since the leading term here is negative, we're going to pull out a negative 2. But what about variables? The first term has x to the third, so technically it has 3 x's. The second term only has 1x. Remember, we're only allowed to pull out what they both have in common. So in this case, that's simply x. So we're pulling out, dividing out negative 2x. So first we're dividing it out of negative 2x cubed. So what is that? Well, negative 2 divided by negative 2 cancel. X cubed divided by an understood x to the first is x squared. Next, we got negative 10 divided by negative 2. Again, negative divided by negative is positive. And I should have highlighted that just to keep it rolling. I'm probably going to stop after this, though, so we can go a little faster. Negative 10 divided by negative 2 is positive 5. And then the x divided by x cancels, and it leaves me simply with x squared plus 5. Okay? The next one, number 3. Again, what can I pull out of 14 and 6? So the biggest number I can pull out of 14 and 6 is 2. Okay, how about the first term? It has m to the 8th. Second term only has m to the 3rd. What's the most they have both in common? M to the 3rd. First term has n to the 5th. Second term has n to the 6th. So we can pull out n to the 5th. The most they both have in common. So here we go. 14 divided by 2, 7. M to the 8th divided by m to the 3rd. 8 minus 3 leaves that with m to the 5th. And of course here the n to the 5th divided by n to the 5th will cancel out. So I'm left simply with 7m to the 5th. Next term, positive 6 divided by 2 is positive 3. M to the 3rd divided by m to the 3rd will cancel. But n to the 6th divided by n to the 5th, there's 1 left, so 3n. So when we pull out 2m cubed n to the 5th, that leaves me inside with 7m to the 5th plus 3n. Okay? Last one of these examples, and then we're going to go to the next method, talk through it a little bit, but I have a couple of examples that kind of take and use both of these methods. So we'll discuss that in a minute. So this one, we got negative 12 and negative 21. So you know you can't use like a 2, but try to think bigger. Okay, 12 definitely won't go. 6 won't go. 4 won't go. So 3. 3 is the biggest value that goes in. Now remember, if that first term is a negative, we're going to pull out a negative 3. Now, that first term has x to the 4th. The second term has just x. So remember, don't pull out more than they both have. So you can pull out an x. Now, I know the second term has a y, but the first term does not. So we cannot pull out a y term. We're just pulling out x. Negative 3x. So here's what we're left with. Negative 12 divided by negative 3 is positive 4. X to the 4th divided by an understood x to the 1st. 4 minus 1 is x to the 3rd. Negative 21 divided by negative 3 is a positive 7. And then, of course, the x's here will cancel, right? X divided by x. But then the y to the 4th has nothing to cancel it out with. So it just drops down. And our result is negative 3x times 4x to the 3rd plus 7y to the 4th. So please remember that your first method, even when we've switched now and we're dealing with other binomials, not just quadratics, but other binomials, you're going to try to find what every term has in common, and you're going to pull it out. Okay? You're going to divide it out. Okay, the next thing that we're going to talk about is, again, something else that you have already done, and that is, because we dealt with it with quadratics, that is perfect squares, right? And specifically, I told you that it's the only time you can take a two-term polynomial, what we call a binomial, and you can factor it into two binomials. It's the only time you can take a binomial and factor it into two binomials. And the reminder of how this works is over here, and I'm trying to highlight it. Of course, it's like I'm coloring badly. But there is the rule. I think you guys are pretty familiar with this. We've done it quite a bit since we learned it. So, reminder. To be a perfect square means a couple of things. One, your number has to be a perfect square. Your number. So, here's some numbers, and we'll go pretty fast, pretty high. we got 1. 2 times 2 is 4. 3 times 3 is 9. 16, 25, 36, 49, 64, 81, 100, 121, 144. We'll just stop right there for a couple of reasons. I'm running out of space. Secondly, most of the time our numbers stay pretty small. If they're bigger than this, what I would recommend is use your calculator to check to see if it's a perfect square. But don't forget, you can also have perfect squares that are variables. And what that means is it has to have an even degree. Well, what does that mean, guys? Well, an even degree means it's got to be something like x squared, or x to the 6th, or x to the 4th, ... Okay, it's got to be an even degree. If it's an even degree, it has to be a perfect square. So the perfect square, as far as numbers go, there's only a limited amount. But the perfect squares, as far as the variable goes, is if it's an even degree, something will multiply by itself twice to get it. Now, let me take you back to number 6. Y'all have done this. I mean, you've done this for sure because that's a quadratic. We factored this. And if you notice, it's just 2 terms. It's a binomial. Well, this does not have a GCF. So that means if I'm going to factor it, the only thing we've talked about that I can factor this problem is if it's difference of squares. And it is. So like I told you, it's the only time a binomial will factor into 2 binomials. And of course, we've laid this out before for you. What multiplies by itself to get x squared? Well, that's x times x. What multiplies by itself to get 49? That's 7 times 7. So, of course, then the rule, as you see over here, for difference of squares, what made that middle term cancel to begin with is the fact that one of these is positive and the other is negative. So we factored this binomial into 2 binomials. Okay? Now look at number 7. Again, look at it first and say, hey, is there a GCF here? Well, nothing actually goes into 9 and 49. Think about it. 9 is only divisible by itself, and 9 won't go into 49. 3 won't go into 49, and 1, which really doesn't help me. So it's a binomial. Is it difference? Well, sure. That's a minus sign. Well, are they both perfect squares? What multiplies by itself to get 9x squared? Well, 3x. How about 49y squared? 7y. So this definitely breaks down into 2 binomials. And y'all just told me the answers. 3x and 3x, 7y and 7y. And then what's the rule? One of them has to be positive and the other negative. Really simple, really simple. Now, number 8, again, don't forget. A lot of times we just kind of start getting in the rhythm of that, and we look at this problem number 8, and we're like, okay, let's see it. Let's do exactly what we just did on number 7. No. Here's why. Can I pull, well, first, those aren't even perfect squares, right? Well, there's a reason. They have a greatest common factor. They have a 2 that I can take out of both of them. 72 divided by 2 is 36, so that's c to the 4th. Minus 2 divided by 2 is 1. So here's my question that I want you guys to consider. Now, is this difference of squares? Well, definitely difference, right? We got the minus sign here. Definitely difference. What about perfect squares? Well, 1 you know is perfect square, right? 1 times 1. But what about 36? C to the 4th. Well, 36 is, right? 6c, or 6 and 6 multiply to get 36. And then since c to the 4th is an even integer, or an even number, it has to be a perfect square, c squared. So that means that, don't ignore the 2, but that means that this is a binomial that will break down into 2 binomials. 6c squared and 1. And what's the rule? 1's plus, 1's minus, and that's done. Okay? Difference of squares. We've done this. The only difference is, definitely look at number 8. Is that a quadratic? No, it's not. In fact, it's a quartic, right? It's a quartic. It's got a big exponent of 4. So these same rules that we learned when we were factoring quadratics, we're applying now. And I know these are the most simple of the ones that we're going to do. Hopefully you get it. Let me show you this one right here. These two actually right here. Let's start with this first one. What can we pull out of 7 and 28? 7. How about m to the 7th and m? I can pull out m to the, or I can pull out m. And then n and n cubed, I can pull out an n. So I can pull out 7mn. Let's see what it leaves me with. 7 divided by 7 is kind of like a 1. M to the 7th divided by m to the 1st is m to the 6th. N divided by n cancels. Negative 28 divided by 7 is negative 4. M divided by m cancels. And n cubed divided by n to the 1st becomes n squared. Here's my question to you guys. We've pulled out the greatest common factor. Is the result difference of squares? So look at difference. Definitely difference. How about squares? Well, isn't this variable's exponent even? Definitely a perfect square. Well, we know 4 is a perfect square, and isn't 2 even? So sure enough, this is difference of squares. This does break down into, and sorry, I accidentally erased that, 6. It is going to break down into 2 binomials. Now, don't forget about all the stuff you've already pulled out, 7mn. So here we go. M to the 6th can break down to m to the 3rd times m to the 3rd. Okay? Process that. Remember, m to the 6th is a perfect square because m squared, or m to the 3rd times m to the 3rd, will multiply where we add our exponents, and 3 plus 3 gives me 6. And then, of course, 4 is 2 times 2. And then n squared is n times n. So those two terms are 2n. And then, of course, our rule is 1 is plus, 1 is minus. And we're done. Okay? We factored out a greatest common factor, and we factored a binomial into 2 binomials. Why? Because it was difference of squares. Okay, last one. I know for sure over here I can pull out a 10. Look, they're both 10. Now, one of them has w to the 5th. One of them only has w to the 1st. So I'm going to pull out w to the 1st. Well, 10 divided by 10 cancels. W to the 5th divided by w to the 1st becomes w to the 4th. And then negative 10 divided by 10 is negative 1. And the w's cancel. So here we're left, for sure, with difference of squares. Look, your variable has an even exponent. And 1 is definitely a perfect square. So that will allow me to break it into 2 binomials. What are they? I hope you said w squared and w squared. 1 and 1. And what are my signs? I hope you said 1's plus and 1 is minus. And that is how you factor using GCF and difference of squares. Okay? I hope you understand that. Now, I could probably jam the difference in sum of cubes. I could probably jam those in, but I'm not going to, for one reason and one reason only. We have done GCF and we have done difference of squares. So this is a concept that we have addressed this year, right? We've addressed it. Well, special cases, difference in sum of cubes, we have not. So this is a brand new thing, okay? Now, the GCF and the difference of squares, that's brand new for polynomials, but the process is the exact same. And since the process is the same, you should remember how to do it. So your assignment, it comes from this page that you either have or you're about to get it. I want you to do number 1, 5, 3, 11, and number 12. Okay? So I know it's only 5, but it's just with this worksheet, since there's so many different ways to factor, and they're all kind of jammed on the same piece of paper, there wasn't as many as I would have liked there to been tonight. But 5 problems is what you've got. Now the video is probably only, I don't know, 20 minutes long or so. But anyhow, you've got plenty of time to do these problems, finish this homework. You'll not see me tomorrow because you'll be either not at school or you'll be taking ASVAB. Might be a handful of you guys taking the ACT. Good luck on those. We'll see you on Wednesday.